Number 1, we're supposed to figure out what sine of 195 is, and I chose to change 195 to 150 plus 45. You can choose other things. Those add up to 195, and they're both going to be special angles. The sum identity is going to be equal to sine of 150 degrees times cosine of 45 degrees plus cosine of 150 degrees times sine of 45 degrees. To continue this, I have to know what sine and cosine are of 150 and 45 degrees. 150 and 45. 45 is going to be in quadrant 1. It's going to make both the legs 1 and the hypotenuse the square root of 2. Sine of 45 and cosine of 45. Sine is y over r, that's 1 over the square root of 2, which is square root of 2 over 2. Cosine of 45 is x over r, that's 1 over the square root of 2, which is square root of 2 over 2. So up here in my equation, I can replace cosine of 45 with square root of 2 over 2. I can replace sine of 45 with square root of 2 over 2. Now I need to figure out what sine and cosine of 150 are. I'm going to end up erasing this because it's in the way of my work, but it's the best I can do because I have a small slate here to work with. 150 is in quadrant 2. That makes the reference angle 30 degrees. Reference angle is the most important part of this. That makes y negative 1. That makes makes y positive 1. Makes x negative square roots of 3. And makes opposite 90 2. Sine of 150 and cosine of 150 we have to know. Sine of 150 is y over r. Cosine of 150 degrees is x over r. So we get negative square roots of 3 over 2 and 1/2. So then we simplify this. 1/2 times square root of 2 over 2 is square roots of 2 over 4. Minus, because we're adding a negative, or you could still leave it plus a negative if you want. Square root of 2 times the square root of 6, square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. So if you put those together, they are not like terms, but they have common denominators. You get square root of 2 minus square root of 6 over 4. That does not reduce. So that's what sine of 195 is. So that's my main work. My side work is over on the left. This next problem is supposed to figure out what tangent of negative 105 degrees is. You can change that to lots and lots of different things that will work. I changed into 150 degrees minus 45 degrees, because that will be 105. Actually, that wouldn't. That'd be 105 positive. Let's change this to negative 150 plus 45. That'd be negative 105. Doesn't matter which pair you use, as long as you use a pair that works. This is going to be equal to tangent of negative 150 plus tangent of 45 divided by 1 minus tangent of negative 150 times tangent of 45. So to finish this, I have to know what tangent is of 45 and 150. 45 degrees, hopefully you know by now, is 1. 45, 45, 90, the legs are the same. Hypotenuse is the square root of 2. Therefore, tangent of 45 degrees is y over x, which is 1 over 1, which is 1. 150 degrees, negative 150 degrees, means we go in the negative direction, which is clockwise, and makes this reference angle 30. Opposite 30 is 1, opposite 60, square root of 3. Opposite 90 is 2. This is in the third quadrant, so both x and y are negative. Tangent of negative 150 is y, which is negative 1, over x, which is negative square roots of 3. If you divide two negatives, you get a positive. If you rationalize this, you get square roots of 3 over 3. So I can go up here and replace some of these things. Tangent of negative 150, square root of 3 over 3, plus tangent of 45 is 1, which I'm going to choose to write as 3 over 3. So I have common denominators. You could write it as 1 first if you wanted. Divided by 1 minus tangent of negative 150 is square roots of 3 over 3 times 1. And once again, I'm going to choose to change this 1 to 3 over 3 so I can subtract those. This side work you don't want to lose. I'm going to erase it just so I have some room here. I do not have a piece of paper, so I don't have a lot of room. Square roots of 3 over 3 plus 3 over 3 is square root of 3 plus 3 divided by 3. Our denominator, when you multiply square root of 3 over 3 times 1, it's just going to be the same thing. So when you subtract those, you're going to get 3 minus the square roots of 3 over 3. I have a complex fraction, which I don't care for. So I'm going to multiply the top and the bottom of my fraction by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. So then I'm going to have square root of 3 plus 3 over 3 minus the square root of 3. Now we're not finished because we're not allowed having a radical in the denominator. So you multiply the top and the bottom by the conjugate of the bottom. Conjugate means the same binomial, but you change the sign between your two terms. Using the distributive property, square root of 3 times 3 is 3 square roots of 3. Square root of 3 times the square root of 3 is going to be 3. The positive times the positive, which is plus. 3 times 3 then is 9. 3 times positive square roots of 3 is going to be 3 square roots of 3. Our denominator, 3 times 3 is 9. 3 times positive square roots of 3 is plus 3 square roots of 3. Negative square roots of 3 times 3 is negative 3 square roots of 3. Those are like terms. One's positive, one's negative, so they end up being 0. Plus negative square roots of 3 times the positive square root of 3 is negative. I wrote plus. That's a negative 3. Simplifying this, we have a plus 3 and a plus 9, which is 12. 3 square roots of 3 plus 3 square roots of 3 is going to be 6 square roots of 3. On the bottom, 9 minus 3 is 6. We can factor a 6 out of the numerator. If you're multiplying the same thing on the top and the bottom, that means you can divide the top and bottom by that thing. 6 divided by 6 is 1. So in conclusion, tangent of negative 105 degrees is equal to 2 plus the square root of 3. That's the final answer. For number 3, you're supposed to figure out what tangent of negative 195 degrees is. I chose to make negative 195 negative 150 degrees plus negative 45 degrees. Once again, you can choose lots of different things. That's what I happen to choose. It's going to be equal to tangent of negative 150 degrees plus tangent of negative 45 degrees divided by 1 minus tangent of negative 150 degrees times tangent of negative 45 degrees. To finish this, we have to know what tangent is of negative 150 and negative 45. Negative 45, you rotate clockwise, that's a negative angle. Put you here in quadrant 4. In a special right triangle, 45, 45, 90, opposite the 45s are the same thing. Opposite 90 is the square root of 2. Since we went down for the y value, that's negative. Therefore, tangent 45 degrees is negative 1 over 1, which is negative 1. Make sure this blue work you see me doing is nowhere close to this problem. You do not want it running into it. I'm going to be erasing it. You also don't want to erase yours. I don't have a lot of space here on this pad, so I'm trying to use my space as wisely as I can. And then negative 150, rotating clockwise, that's going to give us a reference angle of 30 degrees. 30 plus 150 is 180. Opposite 30 is going to be 1. Opposite 60, square roots of 3. Opposite 90 is 2. We're in quadrant 3. We went left and we went down. Tangent of negative 150 is y, which is negative 1, over x, which is negative square roots of 3. That rationalizes to square roots of 3 over 3. Once you know what those are, you put those into your fraction, and I'm going to erase all that work because it's really in the way at this point. Once again, instead of writing negative 1, I'm going to write negative 3 over 3, so I have common denominators. Tangent of negative 150, once again, is square root of 3 over 3. Tangent of negative 45 is negative 1. I also don't want this 1 to be here when I could write it as 3 over 3. I'm going to get rid of my side work. On your homework, don't get rid of your side work. I'm just removing it because it's in the way, which tells you when you do your side work, don't write it so it's in the way. In the numerator, square roots of 3 over 3 plus negative 3 over 3 is going to be square root of 3 minus 3 over 3. In the denominator, when you multiply these together, it's just going to be negative square roots of 3 over 3. When you're subtracting a negative, it's like adding a positive. So that means we're going to have 3 plus the square root of 3 over 3. We have a complex fraction. To make it not complex, I could multiply the numerator and denominator by 3. If we do that, those 3's cancel, these 3's cancel. That is going to give us square root of 3 minus 3 over 3 plus the square root of 3. Square root of 3 plus 3 over square root of 3 minus 3. I think that's what I just said. Let me check. I hope I wasn't recording just now, but I think I was. So this is going to be equal to square root of 3 minus 3 over 3 plus the square root of 3. Can't leave it like this. We have to rationalize our denominator. So we multiply the top and the bottom by the conjugate of the bottom. That means the same binomial, but you change the sign between them. In the numerator, we're going to end up with 3 square roots of 3 and minus 3 minus 9 plus 3 square roots of 3. The denominator, when you multiply two conjugates, it's really just the first term squared, which is 9, minus the last term squared, which is 3. There's 2 more terms in the middle, but they always cancel out. If you didn't realize that, then you should write it out. Combining like terms in the numerator, 3 square roots of 3 plus 3 square roots of 3 is 6 square roots of 3. Minus 3 minus 9 is a minus 12. A plus sign between them. 9 minus 3 in the denominator is 6. I can factor a 6 out of the numerator. I get 6 times negative 2 plus the square roots of 3 over 6. I can divide top and bottom by 6. So in conclusion, I have tangent of negative 195 degrees. It's going to be equal to negative 2 plus the square root of 3, which is the same as saying square root of 3 minus 2. On number 4, we're supposed to find tangent of 165 degrees. I changed 165 to 45 degrees and 120 degrees. So to do this, I'm going to have to know what tangent of 45 degrees is, plus tangent of 120 degrees, divided by 1 minus tangent of 45 times tangent of 120 degrees. So I'm going to do some side work here. I'm going to have to erase it once again just because I don't have enough space. When you write this side work down, put it off to the side away from this so that it doesn't congest it. 45 degrees, phone's ringing, is in quadrant 1. Opposite 45s are 1s. Opposite 90 would be square root of 2. Therefore, tangent of 45, which is y over x, is 1 over 1, which is 1. So into my equation, every place I see tangent of 45, I can replace it with 1. Tangent of 120, make sure you don't erase your side work. I'm doing it because I don't have enough space here. 120 is in quadrant 2, which makes the reference angle 60 degrees. Opposite 30 is 1, opposite 90 is 2, opposite 60 is the square root of 3. In quadrant 2, the x value is negative because we went left. Tangent of 120 degrees is y over x. That's the square root of 3 over negative 1, which is square root of 3 negative. I can replace in this equation for tangent of 120, negative square root of 3. And that occurs in this equation 2 times. Once again, don't erase your side work. I'm doing it because I'm using an iPad and I don't have enough space. The numerator then becomes 1 minus the square root of 3, and the denominator ends up being 1 plus the square root of 3. Radicals on the bottom are inappropriate. So to fix it, we're going to multiply the numerator and denominator by the same thing. That means that we're multiplying it by 1. We're going to choose to multiply it by the conjugate of the denominator. Conjugate is the binomial that has a different sign between your two terms. If you multiply that together, in your numerator, you're going to get 1 times 1, which is 1. 1 times minus square roots of 3, which would be minus square root of 3. Negative square root of 3 times 1 is negative square roots of 3. Negative square roots of 3 times negative square roots of 3 is plus 3. So all over the denominator, you multiply your 1's together, you get 1. Your middle two terms are going to end up canceling. It happens every time you multiply conjugates. If you multiply positive square root of 3 times a subtract square root of 3, you get minus 3. That reduces. Don't erase your work. I'm running out of space. I'm going to throw this to the top of my page here. 1 plus 3 is 4. Minus square root of 3 and minus square root of 3 is minus 2 square roots of 3. Our denominator, 1 minus 3, is negative 2. At this point, I can factor a 2 out of the numerator, or I could choose to factor a negative 2 out of the numerator. You can do either one. I'm going to factor a negative 2 out, which is going to end up giving me it's going to end up giving me negative 2 plus the square root of 3. Because if I redistribute that negative 2, I get positive 4, and I get negative square roots of 3. So I factored that out correctly. Then I can divide the numerator and denominator by this negative 2, and I'm left with negative 2 plus the square root of 3. It was tangent of 165 degrees equals negative 2 plus the square root of 3, or square root of 3 minus 2. Number 5, we're supposed to figure out what sine of 285 degrees is. I chose to break 285 apart into 45 degrees and 240 degrees. Once again, the angles you choose don't matter as long as those angles end up being special angles. Special angles are multiples of 30 degrees or multiples of 45 degrees. Sine of 45 degrees plus 240 degrees is equal to sine of 45 degrees times cosine of 240 degrees plus cosine of 45 degrees times sine of 240 degrees. To finish this problem, we have to know what sine and cosine are of 45 degrees and 240 degrees. We'll do some side work. When you do this work, do it off to the side. Do not do it anywhere close to this equation. 45 degrees is in quadrant 1. Opposite 45s are 1. Opposite 90 is square root of 2. Therefore, sine of 45 degrees is y over r. That's 1 over the square root of 2, which is square root of 2 over 2. Cosine of 45 degrees is 1 over the square root of 2, because that's x over r, which is square root of 2 over 2. So in this equation, every place I have a cosine of 45 or a sine of 45, I can replace it with the square root of 2 over 2. Do not erase your side work. I'm doing it because I don't have enough space. I need to figure out what cosine and sine are of 240 degrees. 240 degrees is in quadrant 3. 240 degrees is exactly 60 degrees further than 180. So it means my reference angle is 60 degrees. Opposite 30 is going to be negative 1. We're in quadrant 3, so it's negative. Opposite 60 is negative square roots of 3. We're in quadrant 3, so we go down, it's negative. R is always positive, it's 2. Sine of 240 degrees is going to be equal to the opposite leg, which is the y value, it's negative square root of 3, over the r value of 2. Cosine of 240 degrees is the x value, negative 1, over the r value of 2. So go back to my equation. I replace cosine of 240 with negative 1/2 plus. I replace sine of 240 with negative square roots of 3 over 2. Use parentheses when you're substituting. Do not erase your side work. I'm doing it because I don't have enough space. If you don't have enough space, use more paper. Multiplying two fractions together. Square root of 2 times negative 1 is negative square roots of 2. 2 times 2 is 4 plus. Square root of 2 times negative square root of 3 is negative square root of 6. 2 times 2 is 4. To add two fractions together that have common denominators, you add or subtract the numerators. These are not like terms, so we cannot actually add them together. Denominator stays the same. This answer could also be written as square root of 6 minus the square root of 2 over 4, and it would be more likely that way if you had chosen your angles differently or written them in a different order. So sine of 285 is negative square root of 2 over negative 6. Pardon me. It's the difference of negative square root of 2 and square root of 6 divided by 4. Number 6, we're told that alpha and beta are angles in the first quadrant. And we're also told to find the exact value of the function. What you see here in red is the function, so we're supposed to figure out. And we're told that tangent of alpha is 4/3 and that cotangent of beta is 5/12. Well, sine of alpha minus beta, what you see here in red, that is equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. So to finish this problem, we have to know what sine and cosine are of alpha and what sine and cosine are of beta. We don't know either of those currently. We're told that tangent of alpha is 4/3. So if I draw my right triangle here, we're told it's in quadrant 1. This is angle alpha. If tangent is 4/3, that means that y is 4 and x is 3, because tangent is y over x. This just happens to be a Pythagorean triple, which means the hypotenuse is 5. If you don't recognize that, use the Pythagorean Theorem and you will figure out that that's 5. Therefore, sine of alpha is 4/5, that's y over r. Cosine of alpha is 3/5, x over r. So in our equation over here, we can replace sine of alpha with 4/5 and cosine of alpha with 3/5. We don't know what cosine and sine of beta are yet. So once again, don't erase your side work. I'm doing it because I don't have a lot of space. So how are we going to figure out what sine and cosine are of beta? Well, we're told that cotangent of beta is 5/12. Cotangent is x over y. So x is 5 and y is 12. Don't know what r is, so if we use the Pythagorean theorem, x squared plus y squared equals r squared. X is 5, y is 12. Don't know what r is. 5 squared is 25, 12 squared is 144. 144 and 25 is 169er. Therefore, r is plus or minus 13. R is the radius, which is always positive, so it's positive 13. Hence, sine of beta is y, which is 12, over r, which is 13. Cosine of beta is x over r, which is 5 over 13. So we can replace in this equation cosine of beta with 5/13 and sine of beta with 12/13. Once again, don't erase your side work. I'm doing it because I nary have enough room. I said nary. You like it. So let me clean this up a little bit. So sine of alpha minus beta is equal to. You need your equal to's, even if your name's Will. 4/5 times 5/13. 4 times 5 is 20. 5 times 13 is 65. Subtract. I could simplify that fraction. I choose not to because I want my fractions to have common denominators, and they currently do. 3 times 12 is 36. 5 times 13 is 65. Once again, I could reduce. Actually, I can't reduce that one. But even if I could, I wouldn't because I want common denominators. Once you have common denominators, subtract the tops, the numerators. 20 minus 36 is negative 16. Bottom stays the same. If that reduces, you should reduce it. It does not reduce. So sine of alpha minus beta is negative 16/65. Number 7, we're supposed to figure out what cosine of alpha minus beta is. So it's going to be equal to cosine of alpha cosine of beta plus sine of alpha sine of beta. We're also told that sine of alpha, this is side work. This shouldn't be below this. You should write this on your paper someplace off to the side. We're told that sine of alpha is 8/17. Well, we have to know what cosine of alpha is. So if you draw your right triangle in quadrant 1, because the directions tell you it's in quadrant 1, sine is y over r. To figure out what x is, you have to use the Pythagorean theorem. So x squared plus y squared equals r squared. Don't know what x is. Y is 8. R is 17. 8 squared is 64. 17 squared is 289. If you subtract 64 from both sides of the equation, you get x squared is 225, which means x is plus or minus 15. In quadrant 1, x is always positive 15. Therefore, cosine of alpha is going to be x over r, which is 15/17. So up here in my equation, I can now replace sine of alpha with 8/17. I could have actually done that at the beginning, so we're given that. Replace cosine of alpha with 15/17. The next piece of information that you're told is that tangent of beta is 7/24. And once again, you're told this is in quadrant 1. Tangent is y over x. So y is 7, x is 24. Once again, do not erase your side work. I'm doing it just so I can show this to you. To figure out what r is, use the Pythagorean Theorem. X squared plus y squared equals r squared. X is 24. Y is 7. We don't know what r is. 24 squared is 576. 7 squared is 49. If you add those together, you get 625. The square root of 625 is plus or minus 25. This is the radius. R is always positive. From this, we can get that sine of beta and cosine of beta. Sine is y over r. Cosine is x over r. So we can replace in our equation cosine of beta 24/25. We can replace sine of beta with 7/25. Don't erase your side work. I'm doing it once again because I've said it 1,000 times. I don't know what you're all watching, if you're watching the whole video or parts, but don't ever erase your side work. Just write it in a place that's helpful. So multiplying here, 15 times 24 using a calculator, that's 360. 17 times 25 is 425. 8 times 7 is 56. 17 times 25 is still 425. When you add those two fractions, you add the top numbers, you don't add the bottom. You're going to get 416 over 425. If those two numbers have common factors, you should reduce it. And I think that you'll find that they don't have any common factors. So I believe this is what cosine of alpha minus beta is. We're told that we're supposed to figure out what sine of alpha minus beta is. Using this difference identity, we'll find that it's sine of alpha cosine of beta minus cosine of alpha sine of beta. So to do this problem, you have to know what those ratios are, those angles. We're also told that cosine of alpha is 15/17 and that cotangent of beta is 24/7. That should give us enough information to figure out what we need to figure out. Well, if cosine of alpha is 15/17, that means that x is 15 and y is 17. Using the Pythagorean Theorem, we should be able to figure out what y is. So we got 15 squared plus y squared equals 17 squared. $15 squared is 225. Don't know what y squared is. 17 squared is 289. Therefore, y squared is 64. So y is plus or minus 8. In quadrant 1, the y value is positive. Therefore, sine of alpha is y over r, which is 8/17. So we know what cosine of alpha is, and we know what sine of alpha is. We need to figure out what sine and cosine of beta is now, and then we can do this problem. Once again, the directions said your angles, alpha and beta, in quadrant 1. Cotangent is x over y. X is 24, y is 7. We're going to use the Pythagorean Theorem to figure out what r is. X squared plus y squared equals r squared. X is 24. Y is 7. 24 squared is 576. 7 squared is 49. 49 plus 576 is 625. Square root of 625 is 25. This is plus or minus. R is always positive because it's a radius. We need to know what sine of beta is and what cosine of beta is. Sine is y over r. Cosine is x over r. So now we know all the ratios that we need to know. Sine of alpha is 8/17. Cosine of beta is 24/25. Minus cosine of alpha is 15/17 times sine of beta, which is 7/25. Don't erase your side work. Make sure that you put it in a good place. I didn't have much of a choice where to put mine, so I'm erasing it. If you have to erase yours, you need to rewrite it someplace. Eight times 24 is 192. 17 times 25 is 425. 15 times 7 is 105. 17 times 25 is still 425. 192 minus 105 is 87. So we get 87 over 425. If that reduces, you should reduce it. It does not reduce. Therefore, sine of alpha minus beta is 87 over 425. Number 9, the directions are verify that the equation is an identity, which means we need to make each side of the equation equal to each other. Cosine of 90 degrees plus theta is a sum identity for cosine, which is cosine of 90 times cosine of theta minus sine of 90 times sine of theta. This is in degrees. Well, what is cosine of 90 and sine of 90? Doing some side work here. 90 degrees is on the positive y-axis. That location, x is 0, y is 1, and r is 1. Cosine of 90 is x over r, that's 0 over 1, which is 0. Sine of 90 is y over r, that's 1 over 1, which is 1. 0 times cosine of theta is 0. 1 times sine of theta is sine of theta. 0 minus sine of theta is negative sine of theta. That's what the right side was all along. Once both sides are identical, then it has been shown it's an identity. Number 10, you're supposed to figure out what sine, supposed to show that sine of pi over 2 plus x is equal to cosine of x. Supposed to verify that that's true. Prove that that is an identity. Well, using the sum identity for sine, sine of pi over 2 times cosine of x plus cosine of pi over 2 times sine of x, that's equal to sine of pi over 2 plus x. Well, what is sine and cosine of pi over 2? Pi over 2 is on the positive y-axis. The reason I know that, 1 complete revolution is 2 pi, half of a revolution is half of that, which is pi. This 2 pi is also 0, you're starting at 0 radians. Half of between 0 and 1 pi is half a pi. That's the positive y-axis. On the positive y-axis, your x value is 0, your y value is 1, and your r value is 1. Once again, we're using a unit circle, which means the radius is 1. Sine of pi over 2 is y over r, which is 1, times cosine of x, plus cosine of pi over 2, that is 0 over 1, because x is 0 and r is 1, which is 0, times sine of x. 1 times cosine of x is cosine of x, plus 0 times sine of x is 0, cosine of x plus 0 is cosine of x, and that's equal to cosine of x. Once you've verified that both sides are the same, then you have shown that that's an identity. Right, number 11, the directions verify this is an identity, make the left side and right side the same is what that means. The numerator on the left is pretty straightforward. That's a difference identity for sine. So we take sine of the first angle, which is beta in this case, times cosine of the second angle, minus cosine of the first angle times sine of the second angle. You had memorized this as alpha minus beta, but this problem is beta minus alpha. So you need to, the alpha and the beta is not magical, is the point. First angle goes first, second angle goes second. This is all over sine of alpha times sine of beta. Now, I don't know if you know this or not, but I'm pretty sure you do. When you add two fractions together, like x over 3 plus, let's say, 2 over 3, you add the tops, which leave the bottoms the same. So you can do this problem from left to right, and it's also true from right to left, which means if you have an equation like, or a fraction like x plus 2 over 3, you could break it apart to x over 3 plus 2 over 3. So what does that have to do with this problem? Well, I look at the right side and there's no fractions. On the left side, I have a fraction. One way to do this would be to take the denominator, which is sine of alpha, sine of beta, and put it with each term in the numerator. And I have no idea if this is going to work. In fact, I had to pause it. I'm not sure where I left off, but I think I was doubting myself if this is going to work. But I'm going to continue anyhow, and if it works, it does, and if it doesn't, you can still learn something from the fact that it doesn't work. So once again, I took the two different terms in the numerator, and I separated them. It's like I unsubtracted the fractions. So is that helpful? Well, it actually is helpful. So in this first fraction, if you're multiplying the top and bottom by the same thing, they cancel and give you 1, which would leave us with cosine of alpha divided by sine of alpha. And on the right fraction, multiplying the top and bottom by sine of alpha, so that's a cosine of beta over sine of beta. That is certainly helpful because then that first fraction becomes cotangent of alpha, and the second one becomes cotangent of beta. The right side was cotangent of alpha minus cotangent of beta the whole time, so we have shown this is an identity. Number 12, we're supposed to verify this is an identity. That means make the left and right sides identical. The left side, I recognize this is the difference identity for tangent. It's going to be tangent of pi minus tangent of theta over 1 plus tangent of pi times tangent of theta. What is tangent of pi? This is side work. Pi is on the negative x-axis. I know that because you start at 0 on the positive x-axis. One complete revolution is 2 pi. Therefore, half of a revolution would have to be pi. On the negative x-axis, the x value is negative 1, the y value is 0, the r value is 1. Tangent is y over x. That's 0 over negative 1, which is 0. So I can substitute here 0 minus tangent of theta over 1 plus 0 times tangent of theta. In the numerator, you get negative tangent of theta. In the denominator, you get 1 plus 0. 1 plus 0 is 1. Negative tangent divided by 1 is negative tangent. At this point, the left and right sides are identical, so we are finished. If you're still watching this video and you're watching number 13, pretty sure there's something wrong with you. And that is you're not using your notes properly. This problem is identical to the ones in your notes. At least I think it is. Your notes are more important than watching these videos, because in the future, it's unlikely your teachers are going to make videos for you, but they will always have notes for you. And if they don't, well, they're notes that you would take. Cosine of 30 degrees minus x. Well, that's going to be equal to cosine of 30 degrees times cosine of x plus sine of 30 degrees times sine of x. That's a difference identity for cosine. Plus. Cosine of 30 plus x is going to be cosine of 30 degrees times cosine of x minus sine of 30 degrees times sine of x. To finish this, we have to know what cosine and sine of 30 degrees are. Opposite 30 is 1, opposite 90 is 2, opposite 60 is the square root of 3. Cosine of 30 degrees, therefore, is square root of 3 over 2. Don't know what cosine of x is. Sine of 30 is y over x, which is y over r, which is 1/2. Don't know what sine of x is. Cosine of 30, once again, x over r, which is square root of 3 over 2. Cosine of x, we don't know what that is. Sine of 30, once again, is 1/2. Sine of x, we don't know what that is. So in continuing this, something I didn't realize, wasn't paying attention. Plus sine of 30 times sine of x and minus sine of 30. Sine of x, like terms, they cancel. Likewise, even if I didn't recognize it then, it's still true now. Minus 1/2 a sine, plus 1/2 a sine, those cancel. And square roots of 3 over 2 cosine of x plus square root of 3 over 2 cosine of x means we're going to have 2 of these square root of 3 over 2 cosine of x's. It's probably best if you combine those at the beginning. And then 2 divided by 2 is 1, so you get square root of 3 times cosine of x equals 2, the right side, which is square root of 3 times cosine of x all along. So, finished.